In this video lesson we are going to study how we can make graphical user interfaces with Java. Here at naturalprogramming.com you will find this icon GUI, and if you click this icon you will enter this page, and there you will find this column of programs, and the title is JavaFX apps. So these are Java applications that use a technology called JavaFX to make the graphical user interfaces. And so I have already downloaded a couple of these programs, the stepsfx.java and the drawing rectangles fx.java. So let's take a look at how these work. So I have them there already, and I can compile them with a normal Java command, and I can run with a normal Java command. And for instance, this stepsfx.java, it displays this kind of thin window where you can see both ascending and descending steps. We will take a closer look at this source code of this program later. So you can compile these programs and run them normally from the command line, and if you would like to use some kind of other tool to compile and run these programs, I will show it. So if you would like to use the NetBeans, we could then make a NetBeans project to run this stepsfx. So I will here create a new project, file, new project, and you don't need to do, when you are running these my examples, you don't need to do a JavaFX project, but you just do a normal Java project, and then you click next, and then you set the name for the project. Steps fx. And the important thing again is that you remove this so-called package name there, and you say there just stepsfx, and then it automatically creates this Java file with that name. And you must do the same thing, this removing the package name with all the examples that are available there. And there it is. It makes it into that location, and you just say finish. So it created this file stepsfx.java, and you just need to download the file and write it over this file. So I will show how to do it. With the right mouse button you can click the file and save link as, and you have to search the NetBeans projects and the stepsfx project and the source subfolder, and there you save the file and you replace the existing file. And then it shows the file here already, and you just press this run project button, and there it is running. So you can run these programs with NetBeans in the same way as you do the traditional Java examples that I have on my site. So I will close it And well, I will also close this whole project because we are not going to use this NetBeans here. We are going to run these programs from the command line, and I have already opened these files in an editor. So let's take a look at how these programs are made. So when we are using this JavaFX technology, we import many things related to JavaFX. So we are using these standard classes provided, and with these classes we can do the graphical things that are visible on the screen. And you can, these JavaFX standard classes, they are available when you use, for instance, the version 8 of Java Software Development Kit. And for instance, this steps.fx program, it looks like this. So there are actually two methods here. There's a start method, and then there is this main method. And in these examples, the main method is always like this. So we don't have to worry about that, and that automatically activates the app. But then the start method is important thing, as that is called at the beginning, and that creates the graphical user interface. And the important thing here is that when we want to create a JavaFX application, we will use the standard application class. So it is imported here, and we derive our own class from this standard application class. And there we redefine the start method, and the start method is automatically called by the system when the app starts, and it provides this states object for us. So we can do things like we set the title for the app, and usually we always have these things in these JavaFX applications, like we specify at least one group, and we specify a skin or create a skin object, and there we set that what is the size of the window, what is the width and height of the window that will be opened, and then this group will then contain all the elements that will be shown on the screen. And we give the group as an argument or parameter when we create the screen object. And in the end, we always do these things, that we set the skin that we have created to the states that was given to us, and then we say that states show, and then the system will show the window. So those are the things that are always present in these JavaFX apps. But let's take then a look at how this particular application is made. And I will run it again. So this app shows these steps, and there are ascending steps and descending steps. And these steps are made so that these ascending steps are objects of type rectangle, and this rectangle is again a standard JavaFX class to specify rectangles to the screen. And here we have some variables like step position X and step position Y, and step size and number of steps to make. And with these variables we control how these rectangles are made. And it's always with these graphical applications, it is important to remember that the 0 point of the screen or window is always at the upper left corner. So here is the 0 point of the window, and for instance when we specify that step position X is 60 and step position Y is 320, it means that this point where the first step is created. So it is in X direction it is 60 points, and in Y direction it is then 320 points. So these steps are made so that the lowest step is the first thing that is made. Or the bottom step is the first thing to make here. And here we create the rectangles, and so that we give parameters like step position X and step position Y. So these refer to the upper left corner of the rectangle. So this point here. And then we count the width of the, so the third parameter is the width of the step, and here at the beginning it is number of steps to make minus step counter, it is 7 times step size. And then the fourth parameter is step size, and that is the height of the step. And then inside this loop, when the step counter is always growing, so it means that the width of each step will be less and less when we make the other steps there. So here is the complete loop. We create the rectangle, and then we set characteristics for the rectangle like the filling color and the stroke color which is the outline, and we also set the stroke width. And then we use this statement. With this statement we refer to the child list of this group, and we add the step there. So this is an array standard. It is an array, this list, and we can use the add method to add new children there. And then we change the step position for the next step, and we increase the x coordinate and we decrease the y coordinate, and it means that the y coordinate is less and x coordinate grows, so the upper left corner of the following rectangle will be this. And this way we can then, when we make the steps, the new steps are always less wide. So we have these standard rectangle objects to make the ascending steps, and then we use these line objects here in this other loop to create the descending steps. And for each line object we give we give this the starting point and the end point as parameters. If we take a look at here, so for instance, this makes the horizontal line, and there, when we make a horizontal line, there is always the y-coordinate is the same always, and the x-coordinate or the endpoint is then more with this value of the step size. So this makes the horizontal line, and this makes the vertical line. And then always we modify these step position x and step position y inside the loop so that these steps will be created correctly. And always we set the color for the line and also the width of the line with these statements. And at the end of each time the loop is executed, we add these line elements to the group. But what is here important to remember that the line is specified that you set the starting point x and y coordinate and the end point with x and y coordinate. And when you create rectangles, you set the upper left corner x and y and the width of the rectangle and the height of the rectangle. So those are important things to remember. So that was the StepsFX program, and if you would like to study these more of the various shapes, there is this shapes demo fx.java available here. And it is also because in this table you will see other programs with the same programs written with other technologies. For instance, this stepsfx.java, in this left column there is stepscanvas.html. So you can see here that the same program made with web technology and JavaScript, but here you can see how it looks like. So if you want to know what these programs do, you can try these web pages here. And for instance, this brick wall canvas.html displays this kind of thing, and then you know that this brick wall fx.java does the same thing with JavaFX technology. And there are even some Kotlin versions of these programs. So because Kotlin is an alternative to Java, so it is possible to use Kotlin to do this. But then you need to install the Kotlin compiler on your computer. All right, let's take a look at another program. So there is this drawing rectangles fx.java. Let's take a look at that. So I will close this one. well, it displays some dirty things there, but I have there this drawing rectangles fx.java already downloaded, so I compile it and I run it. So it shows this window here, and I can just draw rectangles like this. So this program is an example how we can react to the mouse when we are using the JavaFX technology. So let's take a look at how this is done. I have already the drawing rectangles fx.java here. So it says, the comment says, this program demonstrates how to react to mouse events. Lambda expressions are used to specify the mouse-related activities. This program is able to draw a rectangle in a correct way regardless of the direction to which the mouse moves. So there is a special method here that adjusts the coordinates so that the rectangle appears in a nice way. But again, this application is created by deriving a new class from the standard application class. So our own class name is here drawing rectangles fx, and we derive or inherit the application class. And we have some data fields here, starting point x, starting point y. So those points store information about from where the mouse movement started, and again there is this group where the rectangles are stored, and here's also a null rectangle which we use when we are creating a new rectangle, and we have a boolean variable here that controls the process of drawing the rectangle. So we set this to true when new rectangle is being drawn. And then we have an array of colors that we use for the rectangles. And we index this array with this variable color index. So this is adjust rectangle properties. So this will adjust the rectangles so that they look good on the screen. But let's take a look at how we react to the mouse events. So we have, again, everything is written inside this start method. So we have a start method that is called at the beginning when this app starts, and we get the stage object as a parameter. And we specify the scheme, and the initial width of the window is 800 points and height is 600 points. This is the background color of the window, and again there is this main method, and it's always similar in these our examples. And at the end we set the scheme to the states and we show the states. But here are these methods, with these statements we react to mouse events. And we are using here those so-called lambda expressions, so that we say that if mouse is pressed on the screen we will do this thing, and if mouse is dragged on the screen, we do this thing here, and then if mouse is released on the screen, we do these things. So these are now these expressions here, they are now parameters or arguments for these methods. And we receive a mouse event object as a parameter when always when some mouse operation is done. And here, for instance, when the mouse is pressed down, we first test that if it is false, that new rectangle is being drawn, then we can start drawing a new rectangle. And we just get the starting point x and y coordinates from this event object here. So we use the get scene x and get scene y methods to get the coordinates, and they are stored in these data fields, data members, and here we create also a new rectangle, and we used here a snow color for the rectangle, and we add the new rectangle to the group, and we set this variable to true to indicate that we are now drawing a new rectangle. So you can see here that I will rerun this. So you can see here that when we are drawing these rectangles, the rectangle that is being drawn, it is white, but when I release the mouse, its color turns to the final color, like this. And so for that reason, so we are using the snow color here during the process when the drawing is going on, and then we change the color at the end. And then when mouse is dragged, dragging means that the mouse button is pressed down and the mouse moves. So then we just modify the find out what is the current ending point of the mouse, and then we adjust the rectangle properties this way, so that this adjusts the properties that the rectangle looks good. So we give the new rectangle as a parameter for that method, and it automatically sets the coordinates such that the rectangle looks good. So that you can see that if I try to draw a rectangle here, so depending on how I move the mouse, the position of the rectangle is very much different. And this method adjusts rectangle positions properties. Then it fixes the coordinates so that the rectangle looks good. But you can study this on your own if you like. So here, it was here at the beginning. And then there is the final method, there is set on mouse released. And again we test if the mouse is really being drawn, and we then again here we set the color of the final color of the rectangle. So we use this array of colors and we use this index. And after we have set the color, we increment the index for the next rectangle, and if the index is becomes bigger, that is allowed for the array, then we set the index to 0. And here we also, as the new rectangle is now stored into the group, we can mark it as null, and we mark this Boolean variable that we are no longer drawing a rectangle. So this is how this program is made. Again, it's important to notice here that we refer to the scene, which means the whole window, and then we set the mouse activities to the whole scene. It is in JavaFX, it is possible to use here some other object here so that we could set mouse operations for a certain rectangle, for instance. But you can study that in other programs. So this was a quick introduction to making graphical user interfaces with JavaFX. And here you can still find many programs if you want to study these things. For instance, there is this mouse demo fx.java. So it works like this, so that you can find out, for instance, which a mouse button is pressed. Actually, this HTML version doesn't work so well. And there are program that shows how to import characters from the keyboard. And there is program moving balls with mouse FX. So it works like this, that you can move balls like this on the screen with the mouse. And there are like playing cards program. It looks works like this HTML page. You can deal the cards and you can turn them, but that's all you can do. But based on this program, you could create some card playing application. And then there is this, for instance, there is this bouncing ball fx.java that shows how animation is made. The animation will look like this if you compile and run the program. And there is also here a link to the JavaFX programs folder. So you can you will see the folder where these programs are located. And sometimes it is important to see the folder because, for instance, there are some image files there, and some of the programs are using these image files. Okay, this is a quick introduction to JavaFX programming. I hope you liked the video. Thank you for watching and have a nice day.